Why does component aging affect noise performance in electrical engineering? Have you ever wondered how the aging of electronic components impacts noise performance in electrical engineering? This is a fascinating topic that ties into noise reduction, signal processing, and control systems. Let's break it down. Component aging leads to physical and chemical changes in electronic parts. These changes can significantly affect their electrical characteristics and increase noise generation. Over time, factors like temperature, electrical stress, and environmental conditions cause degradation. This includes issues like bias temperature instability and hot carrier injection. These degradation mechanisms shift important parameters such as threshold voltage, mobility, resistance, and capacitance. All of these directly influence how noise behaves in circuits. To understand noise, think of it as unwanted random variations in electrical signals. This noise often comes from thermal agitation, defects in materials, and imperfections in devices. In analog signal processing, noise reduction relies heavily on stable component behavior to keep signals clear and accurate. As components age, their properties change. For instance, resistors may experience resistance drift due to oxidation or mechanical stress. This drift can lead to increased thermal noise since noise power is linked to resistance and temperature. Semiconductor devices, like metal oxide semiconductor field effect transistors, also face aging effects. Bias temperature instability and hot carrier injection degrade parameters like threshold voltage and carrier mobility. This results in increased flicker noise and reduced gain linearity, which worsens noise performance in analog circuits, such as amplifiers. Additionally, aging affects insulation materials and dielectrics. This can alter capacitance and leakage currents, introducing more noise sources and reducing noise immunity. For example, if insulation in cables degrades, it can change their electrical properties, leading to increased noise coupling and signal distortion. In practical terms, the noise degradation caused by aging impacts noise reduction techniques in analog signal processing and control systems. Amplifiers and filters designed to minimize noise depend on predictable component behavior. When aging alters these behaviors, it can lead to a higher noise floor, more distortion, and a lower signal-to-noise ratio. This ultimately affects the quality of signal processing in areas like communications and instrumentation. Understanding how component aging affects noise performance is essential for designing reliable electrical systems. By recognizing these changes, engineers can create systems that maintain low noise levels throughout their operational life.